We'll take a look at this first equation, and the directions asks us to find the derivative for the function q is equal to the square root of 11 minus r to the 7, and we can see the correct answer choice is C. So let's see how that's worked out exactly. We have q is equal to the square root of 11r minus r to the 7th power. In order to find the derivative, we'll use the chain rule. So I'll set my substitution for my outermost function. So I'll let q equal to the square root of u. I can now rewrite the square root as the 1/2 power. So I'll rewrite that as u to the 1/2. And now I'll take the derivative for my inside function. I'll let u equal to 11r minus r to the 7th power. By the definition of the chain rule, dq by dr, that's equal to dq by du, which is the derivative for the outermost function, times du dr, which is the derivative for the innermost function. Now we'll find the factors dq, du, and du dr. To find dq du, we'll simply take the derivative of the following equation with respect to u. So dq du is equal to, I'll use the power rule, the derivative of u to the 1/2 power is 1/2 times the square root of u. Next, I'll back substitute u, which is 11r minus r to the 7th power. Therefore, dq du is equal to 1/2 times the square root of 11r minus r to the 7th power. Next, we'll find the next factor in our chain rule, du dr, which is the derivative for the innermost function. So I'll simply take the derivative with respect to r. So we have du dr. I'll use the power rule. The derivative of 11r is 11 minus the derivative of r to the 7th is 7th r to the 6th power. So we'll put these two factors together. We have dq dr, that's equal to dq du, which is 1 divided by 2 times the square root of 11r minus r to the 7th times du dr, which is 11 minus 7r to the 6th power. I'll simply write this as one single term. So we have dq dr is equal to 11 minus 7 r to the 6 over 2 times the square root of 11r minus r to the 7th power. Now we'll differentiate the function y is equal to 1 plus the sine of 7t, and that quantity is raised to the -3rd power. So we'll in fact use the chain rule twice. So first we'll make a substitution for the outermost equation. So we'll let y equal to u raised to the -3rd power. We'll now make a substitution for our innermost function. We'll let u equal to 1 plus the sine of 7t. Now we'll apply our chain rule. dy by dt. That's equal to dy by du times du dt. So we'll find dy du. So we'll find the derivative for our outermost function. Dy by du, that's equal to -3 times u to the -4th power. We'll back substitute u for 1 plus the sine of 7t. Therefore, dy du is equal to -3 times 1 plus the sine of 7t raised to the -4th power. Now we'll find the derivative of the innermost function du dt. So we have du dt. We'll distribute the derivative operator. Note that the derivative of any constant is 0. And when we find the derivative of the sine of 7t, we have to use the chain rule once again. So let's make a substitution for the outermost function, which is a sine. So we'll let u equal to the sine of v. We'll now make a substitute for our innermost function, and we'll let v equal to 7t. So we apply our chain rule to the given function, the sine of 7t. We have du dv times dv dt. So we'll find the derivative of the outermost function, du dv. The derivative for the sine of v is the cosine of v. We'll now find our innermost derivative, dv dt. We have dv dt is equal to 7. We'll back substitute v for 7t. So we have du dv is equal to the cosine of 7t. Now we'll put all our factors together here. So we have du dt is equal to 7 times the cosine of 7t. Back to our original function, dy dt. We'll substitute dy du for -3 times 1 plus the sine of 7t raised to the -4th power times du dt, which is 7 times the cosine of 7t. We'll now simplify our function, and we have dy dt is equal to -21 times 1 plus the sine of 7t to the -4th power times the cosine of 7t. Next, we'll find the second derivative for the function y is equal to 5x squared plus 4x minus 4. We have the function y is equal to 5x squared plus 4x minus 4. We'll find the first derivative, which is y prime. We'll simply use the power rule. We'll treat 2 as a multiplier and subtract 1 from our exponent. So 5 times 2 is 10, and x is raised to the first power. We'll also apply the power rule for our second term. Remember that x has an understood exponent of 1. So we'll treat 1 as a multiplier, subtract 1 from our exponent, and recall that any number to the 0 power is equal to 1. So the derivative of 4x with respect to x is 4. And as always, the derivative of any constant is 0. We'll now find the second derivative, which is y double prime. So again, remember that x has an understood exponent of 1. We'll treat 1 as a multiplier. We'll subtract 1 from our exponent. Again, the derivative of any constant is 0. and we have the second derivative of our function is equal to 10. We have the function y is equal to x squared minus 3x plus 2 divided by x to the 7th power minus 2. And in order to find this derivative, we'll use the quotient rule for derivatives, which state that the derivative of y with respect to x for a quotient, u divided by v, that's equal to u prime times v minus v prime times u all over v squared. So we'll treat the numerator as u, so we'll let u equal to x squared minus 3x plus 2. Notice in our formula we also need u prime, so we'll take the derivative for u with respect to x. So we have the derivative as 2x minus 3. We'll set our denominator equal to v. So we have v is equal to x to the 7th power minus 2. We also need v prime in our formula. So we'll find the derivative of v with respect to x. So we have 7x to the 6th power. So now we'll find the derivative y prime. So we multiply u prime times v. So we have 2x minus 3 times x to the 7th power minus 2 minus v prime times u. So we have 7x to the 6th power times x squared minus 3x plus 2 all over v, which is x to the 7th power minus 2, and that quantity is squared. Next, we'll simplify the numerator, and we'll leave the denominator in this particular form. So in the numerator, I use the distributive property, and I'll distribute 2x by every term in that second factor, and I also distribute negative 3. So we have 2x to the 8th minus 4x, and now I'll distribute the negative 3. So we have negative 3x to the 7th plus 6. Now I'll distribute negative 7x to the 6th power. So we have negative 7x to the 8th. Remember, when we multiply like bases, we add our exponents. Next, we have a positive 21x to the 7th minus 14x to the 6th power all over x to the 7th minus 2, and that quantity is squared. We'll further simplify the numerator. We'll simply combine like terms. So we have 2x to the 8th minus 7x to the 8th, which gives us negative 5x to the 8th. We have two 7th degree terms, negative 3x to the 7th plus 21x to the 7th is a positive 18x to the 7th. We have one 6th degree term, which is minus 14x to the 6th. We next have a 1st degree term, minus 4x. We have a constant plus 6 all over x to the 7th minus 2, and that quantity is squared. Next, we'll find the derivative for the function s is equal to t to the 4th power times the tangent of t minus the square root of t, and the correct answer is B. The derivative is equal to t to the 4th times secant squared t plus 4t to the third times tangent t minus 1 over 2 times the square root of t. We have the function s is equal to t to the fourth times the tangent of t minus the square root of t. And we'll find ds dt, that's the derivative of s with respect to t. So notice we'll distribute our derivative operator. So d by dt for t to the fourth times the tangent of t, notice that that's one term, minus the derivative with respect to t for the square root of t. When we find the derivative for our first term, notice that it's a product, so we'll use the product rule for derivatives. And the product rule for derivatives states that dy dx for any product u times v, that's equal to u prime v plus v prime u. So we'll set our first factor equal to u. So u is equal to t to the fourth. Notice in our formula we also need u prime, so we'll find a derivative, and we have 4t to the third. We'll set our second factor as v. V is equal to the tangent of t. In our formula we also need v prime. So based on the trig derivatives, the derivative for the tangent of t is the secant squared of t. So we'll put all this together in our formula. We have u prime v which is 4t to the third times the tangent of t plus v prime u, which gives us t to the fourth times the secant squared of t. And then we'll simply take the derivative for our second term. So we have negative 1 over 2 times the square root of t. Next, we'll find a derivative for the function s is equal to t to the eighth minus cosecant t plus 19. We have the function s is equal to t to the eighth minus cosecant t plus 19. We'll find the derivative of the function s with respect to t. So we'll simply take the derivative for every term. So we'll use the power rule. Remember, we'll treat 8 as a multiplier and subtract 1 from our exponent. So we have the derivative of t to the 8th as 8t to the 7th. And from our trig derivatives, we know that the derivative for cosecant t is negative cosecant cotangent. So we'll keep the negative from our problem. We have the derivative of cosine t as negative times the cosecant of t times the cotangent of t. And we have the derivative of any constant is 0. So next we'll simplify our equation, and we have the derivative of s with respect to t as 8t to the 7th plus cosecant t cotangent t. Next we have the function y is equal to 5x minus 4 times 2x to the third minus x squared plus 1. And we have the derivative, and the correct answer is D, as 40x to the third minus 39x squared plus 8x plus 5. So we have the function y is equal to 5x minus 4 times 2x to the third minus x squared plus 1. And we're asked to find a derivative. Notice that we're finding the derivative of a product, so we'll use the product rule for derivatives, which states that the derivative of y with respect to x for any product u times v, that's equal to u prime v plus v prime u. So we'll set our first factor as u. So u is equal to 5x minus 4. Notice in the formula we also need u prime. So we'll take the derivative of u with respect to x. So we have 5. We'll set our next factor v as 2x to the third minus x squared plus 1. Notice in our formula we have v prime. So we'll find the derivative of v with respect to x. So we have 6x squared minus 2x. We'll now find the derivative, which is y prime, and we have u prime times v. So we have 5 times 2x to the third minus x squared plus 1 plus v prime times u, which is 5x minus 4 times 6x squared minus 2x. So now we'll simplify our expression. So here I'll distribute 5. So we have 10x to the third minus 5x squared plus 5. Here I'll distribute 5x, and I'll also distribute negative 4. So we have 30x to the third minus 10x squared. I'll now distribute the negative 4. We have negative 24x squared plus 8x. We'll now combine like terms. So 10x to the third plus 30x to the third is 40x to the third. We'll combine our squares. Negative 5x squared minus 10x squared is negative 15x squared. Minus 24x squared gives us a total of negative 39x squared. We'll now combine our linear terms. There appears to be only one, so we'll bring that down. And there's only one constant. We'll also bring that down. Next, we'll find the derivative for the function r is equal to 2 divided by s cubed minus 9 divided by s. We have the correct solution, which is d, and that's negative 6 over s to the 4th plus 9 over s squared. So r is equal to 2 over s to the 3rd minus 9 divided by s. And the first thing I'll do is use the rule for negative exponents. It states that a to the negative n is equal to 1 divided by a to the positive n. So I'll rewrite the function as 2 times s to the negative 3rd power minus 9 times s to the negative 1st power. When we find our derivative, dr ds, we'll simply use the power rule. We'll treat negative 3 as a multiplier, so we have negative 6. We'll subtract 1 from our exponent, minus, we'll treat negative 1 as a multiplier. The double negatives gives us a positive. We'll subtract 1 from our exponent, which gives us a negative 2. And now I'll utilize the negative exponent rule once again, and we'll write our derivative as negative 6 over s to the positive 4 plus 9 over s squared. We'll find the derivative for the function 13x to the negative second power plus 8x cubed minus 6x. We have the correct answer as D, which is negative 26x to the negative third power plus 24x squared minus 6. So we have the function y is equal to 13x to the negative second power plus 8x cubed minus 6x. We'll find the derivative y prime, so we'll simply use the power rule for each of our terms. We'll treat negative 2 as a multiplier. We have negative 26. We'll subtract 1 from our exponent. We'll use the power rule for our second term, treating 3 as a multiplier. We'll subtract 1 from our exponent. And we'll also apply the power rule to our last term. Remember that x has an understood exponent of 1. We'll treat that as a multiplier. Subtract 1 from our exponent, and recall that any number raised to the 0 power is equal to 1. So we have our derivative as negative 26x to the negative third plus 24x squared minus 6. Next, we'll find the derivative for the function s is equal to t to the ninth plus 7t plus 5 divided by t squared. We have the correct answer, which is A, as 7t to the sixth minus 7 divided by t squared minus 10 divided by t to the third power. We have the function s, which is equal to t to the ninth plus 7t plus 5 divided by t squared. Notice for this problem, we do have a quotient, but in our denominator there is only one term. It's a monomial. So instead of using the quotient rule for radicals, we'll simply simplify the fraction and we'll take the derivative of each term. So I'll treat this denominator t squared as a denominator for every term in the numerator. Next, I'll use the quotient rule. We have t to the top exponent, which is 9, minus the bottom exponent, which is 2. So that's t to the seventh. I'll apply the quotient rule for exponents here again. We have 7 divided by t plus 5t squared. Next, I'll use the negative exponent rule. So we have t to the 7th power plus 7t to the negative 1st power plus 5t to the negative 2nd. We'll now take the derivative with respect to t. So we'll treat 7 as a multiplier. We'll subtract 1 from our exponent. We'll treat negative 1 as a multiplier. We'll subtract 1 from our exponent. And we'll treat negative 2 as a multiplier and subtract 1 from our exponent. Next, we'll reuse the negative exponent rule and we'll write our final derivative as 7t to the 6th minus 7 divided by t squared minus 10 divided by t to the third.